Hello CNC folks. I've laid out my board for my stepper controller. So from the previous videos, two of these boards, 1, 2, will control one stepper motor, and one microcontroller that will fit in this socket will control these two. So this will be for the x-axis, controlling these two boards, and these two boards will take positive and negative here, and then have two leads go into a stepper motor, and then those two more leads go into the same stepper motor. You know, stepper motors have 4 leads. So this microcontroller that I'll populate into this socket will be for the x-axis, and it'll have two boards here and one stepper. This will be for the y. It'll have two more boards, two more of these driver boards, and this will be for the z. It'll have two more for a total of 6 of these boards. Now what I'm doing is I have 12 used leads on here. One in the middle is skipped, and 6 of these pins will be connected through an IDC cable to go to here, and the other 6 on the same cable, I'll split the cable, it'll go to these 6. Now this chip will receive step and direction for the x-axis, and similarly for y and z. There'll be 2 pins used for inputs coming from an Arduino R3 running Gerbil. Now for the microcontroller, I've written my own code to receive interrupts on these 2 pins. It'll service these interrupts and send the signals out to control this LMD 18245 chip. And that's all custom code that I wrote, and it's nice, it works, it's responsive using the interrupts, it handles the steps quickly, and I'm going to have 3 of them, so there'll be no missed steps, and I've tested it out. So this is the board layout. My LDO here is going to power all 3 chips, capacitor for smoothing it out. These are going to be the MSP controller chips, so I need a reset resistor connected to positive, and I'm putting these all in line so the IDC connector can just fit right here and skip a pin in the middle and then be split, go into these 2 driver boards. The reason I don't use the pin in the middle here is because I cut the IDC cable on this end with a scroll saw, and I lose that pin, which comes over here and ends up being in the middle here. So why don't I remove these for now, and I'll show you, I'll just get started soldering these headers and the socket, since I missed that in the last video. This is where it's important to tape down close to the board. Make sure there are no gaps. It'll be really tricky getting this solder socket out if there are any gaps and I need to redo it. So go ahead and solder here. So if you guys want this code that's going to run on this microcontroller, a cheap MSP 430 G2452, I believe, I could make that available. Just subscribe and give me your email address, and I'll email you the code, and you could download that into the chip. It's a very simple way of controlling these steppers. It probably so there you go. One corner done. And the other corner. At this point the tape's no longer necessary, and I got a very flush flush to the board mounting of the socket. This is flush. The top pins are larger than the bottom pins, so there's a little standoff here, but it shouldn't rock back and forth. Okay, let's see how quickly this goes. Using my Radio Shack helping hands. And the microcontroller code has all the wave tables for quarter step, half step, 16th, 8th step with there's some kind of torque control and smoothing control. I put all of those in the code, and it's selectable at compile time when you program the MSP. Heck, I could probably even send people chips if they wanted pre-programmed. Definitely you'd have to subscribe for that and send me your email and I don't know, some money to cover shipping and the cost of the chips and maybe $1 or $2 extra for my time. And these go pretty quickly. I really like these strip boards, not having to waste time bridging pads. I think those all worked very well. Oh no, there's a bunch missing solder on these other sides. I didn't load my soldering tip with enough solder. And I wasn't looking at the phone while I was doing this, the camera phone, which is why I missed it. This camera phone makes a really great magnifying glass. Gerbil is a open source controller program, CNC controller that runs Go code and sends the Go code to these micro chips, these TI MSP 430G chips that are going to be on this board. That's free and it seems like it's updated quite often. Okay, so that one is done. Next I'm going to populate this header pin, 13 pins long. And it occurs to me that you probably need the schematic for this if you wanted to use the code that I could send. So I guess I would have to do that too. Send a schematic. It's a really easy schematic to solder because I took advantage of the IDC cable to make all the connections and everything's in line from the microcontroller. So I don't have to put a whole lot of wires, jumper wires, on this board. I think only about 3 or 4 jumper wires to go to this pin header here, which is not bad for 12 connections. And I won't solder this entire board today because I showed you how I solder on my previous videos. These headers usually go pretty quickly though. I think that looks good. Other side. Thanks for watching.